The objective of this lesson is to add two fractions with denominators of 10 and 100, replacing the fraction with a denominator of 10 with an equivalent fraction with a denominator of 100 when necessary. In previous lessons, students explored the relationship between fractions with a denominator of 10 and those with a denominator of 100. In this lesson, we will build upon this experience as we add fractions, and as we find equivalent fractions to ensure we add fractions with the same denominator. For this lesson, we will use specific colors to identify tenths and hundredths. We will shade tenths in blue and hundredths in red. Let's begin by adding 3 tenths and 6 tenths. We can model 3 tenths as 3 shaded columns. 6 tenths can be modeled as 6 shaded columns. Notice that both representations are shaded in blue, since both addends are a number of tenths. To calculate the sum, we will first shade 3 tenths, then an additional 6 tenths. Our sum is 9 tenths, represented by 9 shaded columns. This process is the same when we are working with addends that result in a mixed number, such as 8 tenths and 4 tenths. To find the sum, we first shade 8 tenths, then an additional 4 tenths. Since only 2 of the 4 tenths will fit in the first hole, the remaining 2 tenths need to be shaded in the second hole. The sum can be stated as a mixed number, 1 and 2 tenths, or as a fraction, 12 tenths. The next equation asks for the sum of 43 hundredths and 29 hundredths. Since we are now working with hundredths, we will shade our diagrams in red. Following similar steps as before, we will first shade 43 hundredths. Now that we have 43 hundredths shaded, we need to shade an additional 29 hundredths. 43 hundredths added to 29 hundredths is 72 hundredths. Let's look at a question that asks us to add a tenth and a hundredth together. 42 hundredths added to 3 tenths. Let's begin by shading a model of each fraction. 42 hundredths is represented in red, while 3 tenths is represented in blue. Next, we can take each representation and copy it onto the sum grid. First, we will shade the 4 columns of red, then 3 columns of blue, then 2 additional squares in red. 42 hundredths is represented as 40 hundredths and 2 hundredths. 3 tenths is represented as 30 hundredths. 3 tenths written as an equivalent number of hundredths is 30 hundredths. The new equation is 42 hundredths added to 30 hundredths is equal to 72 hundredths. Our next equation allows us to decide which fraction to change to an equivalent fraction. 20 hundredths added to 4 tenths. This equation has 2 possible solutions. First, we could change 20 hundredths into a number of tenths. 20 hundredths occupy 2 full columns on the hundredths grid. 2 tenths added to 4 tenths is equal to 6 tenths. One possible sum is 6 tenths. Alternatively, we could change 4 tenths into hundredths. This makes our equation 20 hundredths added to 40 hundredths, which is equal to 60 hundredths. Another possible solution is 60 hundredths. We can verify our solutions by looking at both possible sums, 6 tenths and 60 hundredths. Both are represented by 6 full columns on the corresponding grid and are equivalent fractions. We can therefore feel confident in our solution. It is important to note that while this final question had 2 possible solutions, the previous question had only 1 possible solution. In both questions, we changed tenths into hundredths, but only the final question had a quantity of hundredths that could be changed to an equivalent number of tenths. So only this final question allowed for the possibility of a solution stated in tenths. The objective for this lesson was to add 2 fractions with denominators of 10 and 100 by replacing the fraction with a denominator of 10 with an equivalent fraction with a denominator of 100. We met this objective by reviewing the process to add fractions with like denominators. We then examined which addend could be changed for an equivalent fraction and calculated the sums. We also identified situations in which 2 solutions are possible by using base 10 models.